Hello friends, welcome to H2 Academy. In the last lecture, we have discussed up to question number 6. So we will discuss question number 7 onwards in this particular lecture. Okay, so we are discussing the problems on the central orbit. Okay, so what we have seen in the previous set of lecture is that the differential equation of the central orbit can be expressed in two forms. The first form is in the polar form and second one is the pedal form. Okay, so the differential equation of central orbit can be expressed expressed in can be expressed in polar form or it can be expressed in pedal form. Okay, polar form or it can be expressed in pedal form. So in the polar form we have d2u upon d theta square plus u is equal to p upon h square u square, and in pedal form we have h square upon p cube dp upon dr is equal to p, where p is the central acceleration. And we have u is equal to 1 by r. R is the distance of the point from the pole. Okay, so let us start discussing the questions. So in the first question we have a is equal to r cos of h and theta. This can be written as 1 upon r is equal to 1 upon a cos of h hyperbolic and theta. So we have 1 upon r as u. So we have u is equal to 1 upon a cos of h hyperbolic and theta. So we have du upon d theta is equal to 1 upon a into n sine of hyperbolic and theta. Okay, so let us further differentiate this. d2u upon d theta square is equal to n upon a into n times of cos of hyperbolic and theta. Okay, so we have d2u upon d theta square is equal to n square into 1 upon a cos of hyperbolic and theta. So cos of 1 upon a cos of hyperbolic and theta is u from this particular expression. So let us take this as 1 and this as equation 2. So we have d2u upon d theta square is equal to n square into u. So what we have seen in the previous set of lecture is that the differential equation of central orbit in polar form is differential equation of central orbit in polar form. Polar form is given by d2u upon d theta square plus u is equal to p upon h square u square. So we have p upon h square u square is equal to, let us place the value of d2u upon d theta square. This is n square u plus u. This is n square plus 1 into. So we have p is equal to h square u square into u times of n square plus 1. So this is equal to h square u cube n square plus 1. So from here we have p is equal to h square n square plus 1 upon r cube. So we have the central acceleration is given by this particular expression. So we have p is inversely proportional to r cube. Okay. So we have the law of force as, so the law of force is given by law of force. So the central acceleration is inversely proportional to the cube of distance of point from pole. Okay, because we have the central acceleration is inversely proportional to r. This is our law of force. Let us solve the part 2 of this question. Okay, so we have a is equal to r tan of hyperbolic theta upon root 2. Okay, so we have 1 upon r is equal to 1 upon a tan of hyperbolic theta upon root 2. Okay, so from here we have u is equal to 1 upon a tan of hyperbolic theta upon root 2. Okay, so we have du upon d theta equal to 1 upon a into theta upon 1 upon root 2. 1 upon root 2 sec square hyperbolic theta upon root 2. Let us find d2u upon d theta square is equal to 1 upon a root 2 into 2 times of sec of hyperbolic theta upon root 2 into differentiation of sec of hyperbole is minus sec theta cos theta. So this is minus of 1 upon root 2 sec of hyperbolic theta upon root 2 tan of hyperbolic theta upon root 2. Okay, so we have 1 upon a 1 upon root 2. Okay, sec square of hyperbolic theta upon root 2 is given by du upon d theta. Okay, and we have u is equal to 1 upon a tan of h hyperbolic. This is equal to, so this 2 gets cancelled. So we have 1 upon a sec square hyperbolic theta upon root 2 minus of into tan of hyperbolic theta upon root 2. This is d2u upon d theta square. Okay, so we have d2u upon d theta square is equal to minus of sec square hyperbolic theta upon root 2 into 1 upon a tan of hyperbolic theta upon root 2. This is equal to u is equal to 1 upon a tan of hyperbolic theta upon root 2. This we can place as u. So we have d2u upon d theta square is equal to minus u sec square hyperbolic theta upon root 2. So let us use the differential equation of the central orbit in polar form. So we have the differential equation of central orbit in polar form as d2u upon d theta square plus u is equal to p upon h square u. P upon h square u square is equal to this is u, so u and d2u over d theta square is this expression. So u into 1 minus of sec square h theta upon root 2. So we have sec square hyperbolic theta is equal to 1 minus tan square of hyperbolic theta. So we have u times of 1 minus of, so we have 1 minus sec square h theta is equal to tan square of hyperbolic theta. So this is equal to u times of tan square hyperbolic theta upon root 2 p upon h square u square. So we have p upon h square u square is equal to u times of tan of hyperbolic theta upon root 2 is ua. So u into ua ka whole square. Okay. So we have p is equal to h square u square into u square a square. So we have p is equal to h square a square into u to the power 5. So we have p is equal to h square a square upon r5. So we have the law of force as central acceleration is inversely proportional to fifth power of the distance of the point from pole. Okay. So we have the law of forces p is inversely proportional to r to the power 5. Okay. So let us discuss question number 8. We can solve this. So we have the curve as r is equal to a sine n theta. Okay, so from here we have 1 upon r is equal to 1 upon a cosec of n theta, and this is u. So we have du upon d theta is equal to 1 upon a into minus cosec n theta cot n theta. Okay, minus cosec is cot x times of n. This is equal to minus of n 1 upon a cosec n theta into cot n theta. So we have minus n into u cot of n theta. This is du upon d theta. So now let us further differentiate this. So we have du upon d theta as du upon d theta is equal to minus nu cot of, this is minus nu cot of n theta. Okay, let us further differentiate this. d2u upon d theta square is equal to minus of n du upon d theta into cot n theta plus u times of minus cosec square n theta times of n. So we have minus n into du upon d theta is this one. So we have minus nu cot square n theta minus un cosec square n theta. Okay, so let us further differentiate this. Let's further simplify this. So we have d2u upon d theta square is equal to n square u common cot square n theta plus cosec square n theta. Okay, so we have the differential equation of the central orbit in polar form as p is equal to h square u square d2u upon d theta square plus u. So let us place the value of d2u upon d theta square. So we have n square u cot square n theta plus n square u cosec square n theta plus u. So we have h square u square n square u into 1 plus cot square theta is cosec square theta. This will be cosec square n theta minus 1 is equal to n square u cosec square n theta plus u. Okay, so let us take u common, h square u cube n square and cosec n theta is ua. N square into ua whole square minus 1 plus n square ua whole square plus u. Okay, so u we have taken common, so this will be 1. Okay, u we have taken common. This is n square into ua whole square. N square into ua whole square plus 1. And we have the u here. U is here. So here it is u, here u, and here it is u. So we have taken out. So this is u cube. This is h square u cube n square u square a square minus n square plus n square u square a square plus 1. Okay, this is p. Let us further simplify this. So we have p is equal to h square u cube, which is 2n square u square a square minus n square minus 1. Okay, so we have p is equal to h square 2n square a square u5 minus of n square minus 1 into u cube. So we have p is equal to h square 2n square a square upon r5 minus n square minus 1 upon r cube. So we have the central acceleration as p is equal to h square 2h square a square upon r5 minus n square minus 1 upon r. Okay, this is our central acceleration. We have the law of forces. P is proportional to 2h square a square upon r5 minus n square minus 1 upon r. Okay, this is our answer. Now let us discuss question number 9, how we can solve this. So we have studied in the theory portion of the central orbit is that the differential equation of the central orbit in pedal form is given by differential equation of central orbit in pedal form. Pedal form is h square upon p cube dp upon dr is equal to central acceleration. Okay, so we have r square is equal to 2ap. So we have 1 upon p is equal to 2a upon r square. So from here we have 1 upon p square is equal to 4a square upon r4. So we have let us differentiate this with respect to r. Okay, so this is minus 2 upon p cube dp upon dr is equal to 4a square into minus 4 upon r5. This is 2 upon p cube dp upon dr is equal to 16a square upon r5. So from here we have 1 upon p cube dp upon dr is equal to 8a square upon r5. Let us multiply both sides by h square. H square upon p cube dp upon dr is equal to 8a square h square upon r5. And we have the central acceleration as h square upon p cube dp upon dr. So we have the central acceleration as 8a square h square upon r5. So we have the law of forces P is inversely proportional to r5. That is fifth power of the distance of the point from pole. Okay. So let us discuss second part. We have the second part as P square is equal to AR. So from here we have 1 upon P square is equal to 1 upon A into 1 upon R. So we have minus 2 upon P cube into differentiating this with respect to R. This is dP upon dr. 1 upon A into minus 1 upon R square. So we have 1 upon P cube dP upon dr is equal to 1 upon 2 1 upon AR square. Okay. So let us multiply both sides by h square. H square upon P cube dP upon dr is equal to h square upon 2AR square. This is the central acceleration. So the law of forces P is inversely proportional to R square. That is square of the distance of the point from pole. Okay, this is law of force. What is there in the third part? So we have the third part we have b square upon p square is equal to 2a upon r minus 1. So from here we have 1 upon p square is equal to 1 upon p square 2a upon r minus 1. So from here we have minus 2 upon p cube dp upon dr is equal to 1 upon b square into 2a into 1 minus 1 upon r square. So we have 2 gets cancelled. So we have 1 upon p cube dp upon dr is equal to a upon b square r square. Okay, so we have h square upon p cube dp upon dr is equal to ah square upon p square r square. This is central acceleration. So the p is inversely proportional to r square. This is law of force. Okay. So total 9 questions we have discussed on the topic of the central orbit. Thank you.